Hello everyone, welcome to our exciting session. Today we're diving into fun with magnets. That's right, it's all about exploring the fascinating world of magnets and how they work. We'll look at some cool experiments, learn about magnetic forces, and discover how magnets are everywhere in our daily lives. So get ready for an engaging and hands-on adventure. Let's get started. Let's take a quick look at the contents of today's presentation. We will start with the discovery of magnets, which is a fascinating story about how humans first learned about these invisible forces. Then, we'll explore the different poles of a magnet, which are essential for understanding how magnets work. Moving on, we'll discuss attraction and repulsion between magnets, highlighting the fundamental principles of magnetic interactions. Next, we'll delve into what exactly a magnet is, including how we can make one ourselves, which is a really interesting practical aspect. We'll also cover the properties of magnets to understand what makes them unique. As we go along, we'll compare magnetic and non-magnetic materials, so you can see what materials are attracted to magnets and which are not. We'll look at the various shapes of magnets and how their shape can influence their magnetic properties. The presentation will also include how to make a magnetic compass, which is one of the earliest and most important applications of magnets. We'll discuss some important cautions about handling magnets safely. Additionally, we'll see how magnets are applied in real life, from industrial uses to everyday gadgets. Throughout the presentation, we'll revisit the properties of magnets and their various uses, emphasizing their significance in our daily lives. All these topics connect to give you a comprehensive understanding of magnets, their properties, and their practical applications. Around 4,000 years ago, a Greek shepherd named Magnes was tending his sheep in a region of northern Greece called Magnesia. He would take his herd of sheep and goats up into the mountains for grazing. He carried a stick with him to help control the animals. Interestingly, this stick had a small piece of iron attached at one end. One day, while pulling his stick away from a rock on the mountainside, he noticed something surprising. It was difficult to free the stick. It seemed as if the rock was pulling on it. What happened was that the rock was a natural magnet, and it attracted the iron tip of the shepherd's stick. This is believed to be the discovery of natural magnets, a fascinating moment when humans first learned about magnetic materials. And as you can see, this natural magnet on the hillside was how we first encountered this incredible force of nature. Let's talk about magnets. A magnet is a material that has the ability to attract certain other materials, like iron, cobalt, and nickel. These materials are known as magnetic materials because they respond to the magnetic force. Now, there are two main types of magnets that we see around us. The first is natural magnets, which occur naturally in nature, like lodestone. The second type is artificial magnets, which are man-made, such as the magnets used in electric motors or refrigerator doors. Understanding these types helps us see how magnets are used in everyday life and in various technologies. This connection between natural and artificial magnets really highlights the importance of magnetism in our world. Today, we're going to explore the different types of materials based on their magnetic properties. First, let's talk about magnetic materials. These are materials that are attracted to magnets, which makes them very useful in many everyday applications. For example, materials like iron, cobalt, nickel, and steel are all magnetic. You might recognize steel from tools or appliances, and these materials are essential because they respond to magnetic fields. On the other hand, we have non-magnetic materials. These are materials that do not get attracted to magnets at all. So, if you try to hold a magnet near wood, plastic, rubber, or glass, nothing will happen. They won't be attracted. These materials are used in situations where magnetic attraction isn't desired or needed. Understanding the difference between magnetic and non-magnetic materials helps us choose the right material for various engineering, construction, or everyday purposes. It's a fundamental concept that connects to how we design and work with different objects and devices. Magnets come in different shapes, and each shape has its own unique features and uses. For example, the most common type is the bar magnet, which is rectangular or cylindrical and often used in experiments and demonstrations. Then we have the horseshoe magnet, which is shaped like a U or horseshoe, and its design helps concentrate the magnetic field at the ends, making it very effective for picking up small metal objects. Cylindrical magnets are also widely used, especially in electronic devices and motors. Recognizing these different shapes helps us understand how magnets are applied in various practical situations and how their shapes influence their magnetic properties. Throughout this presentation, we'll see how these shapes are tailored for specific applications, highlighting the versatility of magnets in our daily lives. Now, let's talk about the poles of a magnet. The two ends of a magnet where the attraction is strongest are called its poles. Specifically, a magnet has two poles, the North Pole and the South Pole. When you freely suspend a bar magnet, it naturally points in the north-south direction, which helps us identify these poles. The end that points toward the north is called the North Pole, and the end that points toward the south is called the South Pole. It's important to remember that magnetic poles always come in pairs. You can't have just a North Pole without a South Pole nearby. In fact, if you try to break a magnet into parts, each new piece will still have both a north and a south pole. When you break it, the two parts essentially become separate magnets, each with its own pair of poles. New magnetic poles develop at the broken ends, which is a fascinating aspect of magnetism. Understanding the poles is fundamental because they are the regions where magnetic forces are most concentrated, and they influence how magnets interact with each other and with other magnetic materials. This concept ties into the overall theme of magnetic properties and helps us grasp how magnets work in everyday life. Let's explore how to make a magnet through a simple activity. First, take a rectangular piece of iron, or alternatively, a needle, a blade, or an iron nail. Place it gently on the table. Now, take a bar magnet and position one of its poles at one end of the iron piece. Next, start moving the magnet along the length of the iron, from one end to the other. It's important to do this repeatedly, about 30 to 40 times. During this process, the magnetic influence gradually aligns the tiny magnetic domains within the iron, turning it into a magnet itself. Once you've finished, lift the magnet away, and you'll notice that the iron piece now behaves like a magnet. This activity demonstrates how magnetism can be induced in certain materials through repeated magnetic contact. This is a key concept because it shows us the process of magnetization, which is essential for understanding how magnets work and how they can be created. It also ties into the larger theme of how magnetic properties can be transferred and induced in different objects. Today, I want to talk about the magnetic compass, an essential tool for navigation. A magnetic compass is used to find directions, helping travelers and explorers determine which way to go. The device consists of a metal case, which provides durability, and a glass cover that allows us to see the inside components clearly. Inside, there's a magnetic needle that can rotate freely, and this is the key part of the compass. Because it's magnetic, the needle aligns itself with Earth's magnetic field, pointing toward the magnetic north. The compass also has a dial marked with the four main directions, north, east, south, and west, so users can easily identify their heading. The needle pivots smoothly on a fixed point, allowing it to respond quickly to changes in direction. Overall, the magnetic compass combines these simple yet clever components to help us navigate effectively, connecting to the broader theme of understanding and utilizing Earth's natural features for exploration. Let's walk through how to make a simple magnetic compass. First, you'll need an iron needle and a bar magnet. The key here is magnetizing the needle by rubbing it with the bar magnet. This process aligns the tiny magnetic domains inside the needle, turning it into a tiny magnet itself. Once it's magnetized, carefully insert the needle through a piece of thermocol or some lightweight material so it can float freely. Then, place the floating needle in a cup of water. When you do this, you'll notice that the needle naturally points in the north-south direction. This simple experiment demonstrates how magnetism can be used for navigation, which is a fundamental concept in understanding how compasses work. The most important idea here is that a magnetized needle aligns itself with Earth's magnetic field, helping us find directions. This ties into our overall theme of understanding Earth's magnetic properties and how they aid in navigation. Let's talk about attraction and repulsion between magnets. You'll notice that opposite poles of two magnets, like the north and south, naturally attract each other. This is a fundamental property of magnets and really important to understand. On the other hand, when you have similar poles, say north and north or south and south, they repel each other. This push-away effect is just as essential. These interactions are at the core of how magnets work and connect to the broader theme of magnetic forces and their behavior in different situations. Remember, the key idea here is that opposite poles attract, and like poles repel. That's what drives much of magnetic activity and applications. Let's talk about some key properties of magnets. First, magnets attract certain materials like iron, cobalt, and nickel. These materials are what we call magnetic materials, and they are strongly attracted to magnets because of their magnetic properties. This attraction is what makes magnets useful in many everyday applications. Next, if you take a magnet and suspend it freely, it will always point in the north-south direction. This is because of Earth's magnetic field, which acts like a giant magnet. The end of the magnet that points north is called the North Pole, and the other end is the South Pole. Understanding these properties helps us see how magnets interact with their environment and why they are so important in technology and navigation. So, in summary, magnets attract specific metals and have a natural tendency to align along Earth's magnetic field when freely suspended. Now, let's talk about another important property of magnets. When we look at the poles of two magnets, the rule is quite simple but very interesting. Opposite poles, meaning the north pole of one magnet and the south pole of the other, will attract each other. This is what makes magnets stick together in a very natural way. On the other hand, similar poles, like north to north or south to south, will repel each other. They push away from each other, which is why you often see magnets resisting trying to line up in the same direction. Understanding these interactions helps us see how magnets behave in everyday life and is fundamental to many magnetic applications. So remember, opposite poles attract, similar poles repel. That's a key principle in magnetism. Now let's talk about some important cautions when handling magnets. First, it's crucial to never drop magnets from heights. Dropping them can cause damage to the magnetic material or even cause the magnet to chip or break, which can reduce its effectiveness. Next, avoid heating a magnet. High temperatures can cause the magnetic domains inside to become disorganized, leading to a loss of magnetic strength. Similarly, do not hammer a magnet. Applying force in this way can also damage the internal structure and diminish its magnetic properties. These precautions are key because they help us preserve the magnet's strength and functionality over time. Remember, taking good care of your magnets ensures they perform reliably in your projects and experiments. So, always handle them gently and avoid actions that could compromise their magnetic integrity. Now, let's talk about some important cautions when it comes to magnets. It's crucial to keep magnets away from electronic devices like radios, televisions, and music systems. These devices rely on magnetic fields, and a strong magnet can interfere with their operation. The same applies to computers, mobile phones, and storage media such as cassettes and compact discs. Magnets can cause data loss or damage these devices. So always be mindful of where you place magnets and avoid bringing them close to your electronic gadgets. This is an essential safety tip to protect your devices and ensure they function properly. Now, let's talk about storing your magnets safely. It's really important to keep them in a secure place to prevent any accidents or damage. Magnets can be quite powerful, and if they snap together unexpectedly, they can cause injuries or break. So always store them away from electronic devices, credit cards, or anything that could be affected by magnetic fields. A good tip is to keep them in a dedicated container or on a shelf where they won't fall or get knocked around. Remember, taking these simple precautions helps ensure safety and prolongs the life of your magnets. This ties back to our overall theme of handling magnetic materials responsibly and safely. Now, let's talk about some of the practical uses of magnets in our daily lives. One of the most well-known applications is in compasses. Magnets help us find directions by aligning with the Earth's magnetic field, making navigation much easier. In factories, magnets are incredibly useful for lifting heavy masses of iron. Instead of using cranes or other machinery, workers can use powerful magnets to move heavy metal objects quickly and safely. Magnets are also essential in the construction of various devices like telephones and electric bells. Their magnetic properties allow us to create the electrical currents and signals needed for these devices to function properly. As you can see, magnets play a vital role in many areas, from navigation to manufacturing and communication technology. They truly are a fundamental part of modern life. Now, let's talk about some more interesting uses of magnets. One important application is in separating iron and steel from non-magnetic materials. This is especially useful in recycling industries, where magnets help efficiently sort metals from other waste. Another fascinating use is in medical technology. Magnets are crucial in devices like pacemakers, which help regulate heartbeats, and in magnetic resonance imaging, or MRI, which provides detailed images of the inside of the body. These examples highlight just how versatile and essential magnets are in our daily lives, from industrial processes to advanced healthcare. They truly demonstrate the incredible power and usefulness of magnetic technology. Now, let's delve into the application of magnets, specifically focusing on a common question about artificial magnets. The statement here is, "Artificial magnet was discovered in Greece." To answer this correctly, we need to understand where the first magnets came from and who actually discovered artificial magnets. The key point is that natural magnets, like lodestones, were known to the Greeks, but artificial magnets, which are human-made, were actually first developed much later. The discovery and development of artificial magnets took place in England during the 1600s, thanks to William Gilbert, a pioneering scientist in magnetism. So, when we look at the options, if Greece were the first place where artificial magnets were discovered, the statement would be true. However, since it was actually William Gilbert in England who made that breakthrough, the statement is false. This distinction highlights the evolution from natural to artificial magnets and emphasizes the importance of understanding the historical context. Remember, the correct answer here is option B, false. This also ties back to our overall theme of understanding how magnetic materials have developed over time and their applications in various technologies.